Now let's look at linear functions and exponential functions and see kind of what they are and how they work together. So a linear function is a function that grows or decays by adding or subtracting the same amount to the output for one change in the input value. A general way that a linear function is written is y equals mx plus b. In this form, the growth factor is the number represented by m, also known as the slope or rate of change. It is also the same number that is added or subtracted, so that is why it is linear. The vertical intercept is always when the input is 0. If you put the input of 0 into a linear function, you always get whatever the b is. So the vertical intercept is always 0b. An exponential function is a function where to one increase in the input value changes the output value by multiplying or dividing by the same amount. A general exponential function can be written as y equals a times b to the x. In this form, the growth factor is represented by the letter b and is also known as the common ratio or the base. The vertical intercept is 0a. One quick note, the equation y equals mx plus b and the equation y equals a times b to the x can be written with different letters. Also, instead of writing y, you can also write other letters for the name. Sometimes the name is written as f of x equals mx plus b, and g of x equals a times b to the x. One comment, f of x and g of x are the name of the function. It does not mean that f is multiplied by x. It's just its full name. So example 1. On December 31st at around 10 p.m., you are sitting quietly in your house watching a New Year's Eve show when there's a knock on the door. Wondering who could possibly be visiting at this hour, you head to the front door to find out who it is. Seeing a man dressed in a three-piece suit and tie and holding a briefcase, you cautiously open the door. The man introduces himself as a lawyer representing the estate of your recently deceased great-uncle. Turns out your uncle left you some money in his will, but you decide how to receive your inheritance. The man in the suit explains that there are three options for how to receive your allotment. Option A, you get $1,000 will be deposited on December 31st in a bank account bearing your name, and each day an additional $1,000 will be deposited until January 31st. That's option A. Option B, 1 penny will be deposited on December 31st in a bank account bearing your name. Each day the amount will be doubled until January 31st. And then option C, take $30,000 on the spot and be done with it. Given that you have been to a party earlier that evening and your head is a little fuzzy, you wanted some time to think about it. The man agrees to give you until 11:50 p.m., which option would give you the most money after the 31 days. Before making any calculations, which option would you select according to your intuition, sorry. Without any calculations, I would instinctively choose the following options and then mark where your answers. Would you take option A, option B, or option C? I'm not going to give you my option, but you just write down what option you would go with. Note that December 31st is time equals 0. Option A, $1,000 to start plus $1,000 per day. Option B, 0.01 to start and then doubles each day. And then option C, again, is just $30,000 right now. So here's your table of input and output values. And what we're going to do is we're going to fill in this table together and see what we come up with. So again, at time equals 0, T is time in number of days since December 31st. The amount in the account after T days in option A, the amount in the account after T days in option B, and the amount in the account in T days after option C. So option C, you get $30,000 done. You get nothing more there. So that one is not going to change at all. After 1 month, option A, you're now going to have another $1,000 deposited, which means you're now going to have $2,000 in that account. So this is looking pretty good. $2,000 is in that account right now. For option B, you had 1 penny. You're now going to double that and get 2 pennies. Again, option C, nothing's changing. Second day, you're going to get another 1,000 put into your account for option A, which means you're now going to have $3,000 in that account. Option B, you're going to double it. So instead of having 2 cents, you're now going to have 4 cents. Option C, nothing changes. Third day, you're now going to be at $4,000 in that account because another 1,000 was put in. But we're doubling again on option B. So instead of being 4 cents, you're now going to have 8 cents in there. We're going to keep the same pattern. 4 days, you're going to have $5,000 in that account because another 1,000 was added. We're going to now double that. So it's now 16. 5 days, you're going to add another 1,000. Going to double it, 0.32. 6 days, another 1,000, double it is 64.64. Day 7, you're going to have 8,000 in there. And we're doubling, whoops, too big. We're doubling. So it's no longer going to be a penny, under $1. It's not going to be $1 something. It's not going to be $1.28. 9,000. And we're going to have 2.56. 10,000. And we're going to have 5.12, because again, we're doubling every day. On day 10, we're going to have 10,000. Day 10, we're going to have 11,000. And we're going to have 10.24. Still looks like option A is the better option at the moment, but let's keep going. 12,000, because we're going all the way to 31 days. So 12,000. This one's now going to be $20.48. We're now going to be at 13,000. And we're going to be at 20, oops, not 20, 40. 40.96. 14,000. We're now at 81.92. And I can keep doing this. We can keep doing this all the way. I'm going to go ahead and do a little bit faster here. I'm going to go ahead and just keep doing the A for a moment. So we're at a 15,000, 16,000, 17,000, 18,000, 19,000, 20,000, 21,000, 22,000, 23,000, 24,000, 25,000, 26,000, 27,000, 28,000, 29,000, 30,000. Ooh, that was what we were going to get an option C was 30,000. But now we're going to notice that at 30 days, we're already going to be at 31,000. So it looks like option A beats option C. In fact, option A goes to 32,000. So it looks like option A definitely is better than option C. Wonder which one you picked. But we're going to keep going with option B. So we doubled it. So now we're going to double this again, and we get 163.84. Doubled it again. We're at 327 and 68.68. And then we double that again. We're at 655.36. Double it again. We're at 1,310.72. Double it again. We're at 2,260. 2,621.44. Double it again. We are now at 3,000 342 and 88.88. Then we're going to double that again, and we're at 10,485.76. The 76 cents is really important, so we're going to keep that going. Then we got to have 20,971.52. Wait, 20,000. We're at 32,000. Huh. Wonder what's gonna happen when we double it again. Oh, we're gonna double that. Which means we're now at $41,943.04. So wait, we just doubled it and we just got on day 22, we got more than we're gonna get with the other one. Ooh, maybe option B is gonna be a better option. Let's keep going. Doubled it again, we're gonna get 83,886.08. Doubled it again, we're gonna get 167,772.16. Looks like we're doing better than option B, option A. So maybe we should have gone with option B. I don't know which one you went with, but let's keep going. We're going to double it again. We get 335,544.32. Double that again. We're going to be at $671,088.64. Double it again. We're going to be at 1,343,177.28. Then double that again. We're going to be at 2,684,345.56. Double that again. We're at 5,368,709.12. Double that again. We're now at 21,737,418.24. And double that one more time, you're at 21,474,836.48. Notice that option C is surpassed by the other two options, so hope you didn't pick that one. Option B way surpassed the other two options. Let's see if we can understand what is going on with these two different options. So first, what is the practical domain and range of each of these functions? So that's the first question we should kind of think about is in here, our practical domain is starting on times 0. Looking back over here, we started on times 0 and we went to times 31. We couldn't keep going any more days than that because we weren't going to be doubling anymore. So nothing more was going to happen after 31 days. So for all of these, the practical domain is 0 is less than or equal to time is less than or equal to 31. For all of these. Though option C actually is just time equals 0, but we're going to go ahead and just put this down because you only got the money once and you never got it again. So that one's a little different. The practical range, however, is different. So here you're starting with 0 money. So that's the smallest amount you're going to have. And then let's just say instead of using time, I'm going to use, let's see, what did I call this over here? We call this the amount. So we'll just call it A of t for the amount. So maybe I should do that. A of t is the amount at time t. T months or t days, because that's what we were dealing with. And the maximum we got for option A was 32,000. So that's my practical range. My practical range there is 32,000. For option B, the maximum I got to is 21,474,836. So we're say 21 million. I keep doing that. 21 million, 474, 837, let's call it. And for option C, your practical range was just that one value. So it was just 30,000. So there's really nothing more to do that. A of t is just 30,000. There is nothing more that will ever happen with that. We're going to graph the three options using the data. So notice that the home window, so we're going to use the data itself. So we're going to see kind of what this looks like using this data. So we're going to go ahead and type these numbers into, let's say, Desmos. You can also do this on your graphing calculator, but we're going to do this on Desmos. And so to make this, you're going to do this, you're going to actually do a table. And we're going to have our x's are going to go from 0 to 1 to 2. And notice it starts filling in for you. So we can just keep going all the way down to 31. Then we're going to go back up to the top and we're going to have y1. You don't have to call it y1. You can call it anything you want. You could have called this not x1. You could have called it t. But let's just use x1 and y1 for right now. And then we started with 1,000. Then we went 2,000. 2,000. I didn't do that one right. 2,000, 3,000, 4,000, 5,000, 6,000. And again, I'm just going to type all these in. Now, I'm going to cheat a little bit because this is going to get a little boring. So I actually have these up for me. So I'm actually going to go and open this file so that I don't actually have to type all these in. But you would have to type all these in. And so we're just going to kind of open this up and see what this is. Functions and exponential. Okay. So you can actually sometimes do this. If you have the data set, you can actually just copy and paste because it's going to take a long time to type all this in and we don't want to do that. So we're going to go ahead and we have them all here for us. And I can actually just go copy all of these all the way down to here. Copy these. And now I can just come over here and I'm going to X this out and I'm just going to paste and it just puts them in there for me. So that's kind of a nice feature. I can also do my last one, which is, we'll call this one W1. And if you just start typing W and then put a 1, it'll put as a subscript. And that was my 30,000. And just so that I can have all of this in there, I'm just gonna keep kind of typing them all in there. So I have all those. And oops, 50,000. And I can actually copy that 30,000. And I can just keep typing them in and just pasting them in so I don't keep typing them wrong. I'm just pasting them in all the way down. So I have them all in there. Oops. Didn't need to jump all the way down. All right, so now I can see all of them on there. Sort of. I don't really see a lot of it on here. I see both the 30,000 and the other one, the option A. So here's option A and here's option C. I don't see all of option B. So what I want to try to do is figure out how do I get all of option B on here so I can see all of it. And that's where those practical range and practical domain helps me. So I also don't need any negatives here because we're starting at 0 and we're going to 31. So I can actually click on the little wrench and I can take my x-axis, and I like to see the x-axis a little bit, so I put in to start with a -1, and I'm going to go up to 32, let's just say, just so I can see the last bit of it. And then my y, looking at my practical ranges, my y should go from 0. Again, I go just slightly less than that just so I can see the axis. I'm going to go all the way up to 20 million. In fact, we're going to do 20 million, 470, let's just say 475,000. 20,475,000. Um, okay. And now I can see more of my red one. I don't know if I did that right. 21,475,000. Let's try that. So now I can barely see my one, my option C. I can't even see my option A. My option B is sort of there. My option A sort of gets lost in all this. So I can sort of see what's going on. I think I'm still typing too many numbers in here. So we're going to go to, let's make this into a 6. There we go. I see a little bit more of it now. But this tells me that option B is way better than the other options. So there's my graph, and that's what I can see happening. So I went to um, the option B's practical domain and practical range, so I can see more of that one. And then I noticed now I can no longer see option A and C. So now based on the graph, which group option would give you the most money after 31 days? Well, it's obviously option B. It doesn't sound like it at start. It sounds like it's not going to be the best method. All right, now let's see if we can understand why option B is growing so fast. Let's just focus on option A and B. Let's take a look at the data values that are given. Just the latter part of the initial value was provided. So I'm just giving you some of it, not doing all of it again. As t increases from day 20 to 21, describe how the outputs change for each function. So option A, it looks like all that happened is we added $1,000. Option B, we doubled it, right? So that's what we did. So that's how that one changed, is that we multiplied the output by 2 each time. Actually, it's not multiplied by 2, we're doubling it. So well, actually, yeah, if I took this one and divided it by this one, I'd get 2. So we're doubling it each time. As t increases from day 23 to 24, again, we added $1,000 for option A. And option B, if you again divided these two, you would then multiply by 2. So in general, we can say as the inputs increase from day from one day to the next, then the outputs of each function, they add 1,000 in option A, and they multiply, the output multiplies by 2. All right, it may be easy to write the function representing option A as A of t and write option B as B of t. As A of t, the slope is m equals 1,000, and the vertical intercept is 0, 1,000. So the equation would be 1,000 plus 1,000 t. For option B, the base is b equals 2, and the vertical intercept is 0.01. So the equation would be b of t equals 0.01 times 2 to the t. We have just identified the primary difference between linear functions and exponential functions. The outputs for linear functions change by addition, and the outputs for exponential functions change by multiplication. And that's the main thing you should get out of all this.